The second type of reaction is addition reaction. So addition, this is probably the most useless definition that I have found for any word. The action of adding is addition. That's just great, isn't it? Doesn't tell you anything. Okay, this is probably pretty good to join or to attach. Yeah, we can stick with that. So an addition reaction is when you attach extra atoms or group of atoms into something. So that's addition. Let's give a generic example. Let's say I have A going to B, and then I have C and D. So this is my generic example. Notice how there's a double bond here between A and B. And then if it can undergo addition, then what is going to happen is that you're going to try to attach C and D into the original molecule. So in terms of addition reaction, you might have something like this. Okay, so I have attached or joined these two atoms into the original molecule between A and B. So a fundamental difference between a substitution reaction and an addition reaction is that in the case of an addition reaction, as the name suggests, you are adding the reactants together. So you should end up with one product from two reactants. So two reactants, and I'm being very specific to organic reactions here, two reactants going to one product. Whereas in the case of a substitution reaction, you start with two reactants and you end with two products, and you just have some replacement of atoms between the two reactants. In this case, you're adding them together, as the name suggests. All right, so addition reactions, if you look back at my generic example here, in order for you to be able to add extra atoms or group of atoms into an organic molecule, that original molecule has to be unsaturated. So it needs to have potential, if you will, to have more things added to it. If it's already saturated with hydrogen, there's really nothing else that you can add. The only thing you can do is substitute. But if a molecule is unsaturated, there is potential for extra atoms to be added. So an addition reaction only occurs between, let's just write it here, sorry. Addition reaction will occur if you have unsaturated hydrocarbon. Now, there are two types of unsaturated hydrocarbon. You either have alkenes, which contain CC double bond, or you have alkyl, which contains CC triple bond. But in the context of VC, we almost only look at CC double bond. So we really don't look at additions of alkene, but just keep in mind that alkyl can do the same thing, probably even more things being added to it. But we're going to focus on alkene only. So in order for an addition reaction, what you have to do is you have to break one of the bonds in the CC double bond. And so there's still one CC bond remains, but you've broken one of these two. And then if you break it, so let's just say if I have a CC double bond, let's say this is ethene, which is the smallest alkene possible. So I have a CC double bond here. Now, if for some reason I manage to break it, so you have this. So I have broken one of the CC double bonds. Then what actually happens here is that you have created two extra vacant spot. So you have one here and you have one here, because every carbon atom needs to form four covalent bonds. So if you have broken one of these double bonds, you have two extra spots here. So this carbon can form a covalent bond with another thing, and this carbon can form covalent bond with another thing. And this is how you can add two different things, one onto each of the carbon in the original CC double bond. So if I just have let's not use C. Let's say I have, I don't know, anything here. So let's say you have this and another thing like that. So you have two, again, this is my generic example. Let's say you have this thing. This thing can now be added to one carbon, and this thing can be added to the other carbon, or the other way around. So two reactants going to one product. And the nature of this other reactant is going to determine, that looks like a face, it's going to determine what kind of product you can have. But essentially in all addition reactions, you're going to break one of the bonds in the CC double bond, which creates two vacant spots, one on each carbon, for two different things to be added to it. Okay, so let's start with addition of hydrogen gas, or hydrogenation is the name. So this is when the other reactant is hydrogen. So I'm going to use the example of ethene again. So I start with ethene. Again, you have a CC double bond here, and because this is an addition reaction, I'm going to break one of the bonds in the CC double bond. I haven't actually done anything else besides that, but these two carbon can now take on one group of atoms each. So if the other reactant is H2 or hydrogen gas, one of the hydrogen is going to go form to here, and the other hydrogen can be added to here. So this is how you make an alkane from an alkene by a process called hydrogenation or addition of hydrogen. It normally requires a catalyst. Nickel is the common one. Actually, also you need 500 Celsius degree. So 500 degrees Celsius or very high temperature. So that's the first type of addition reaction, hydrogenation. Now, if I replace the hydrogen with H2O, then you can have another product. So let's say we have, let's just make life a little bit more exciting. I'm going to use propene here, even though I have to draw a lot of hydrogen. That's fine. Okay, so let's say we have propene. You know that this is an addition reaction, so the CC double bond, one of the CC double bond will be broken, so you still have one bond left. Then you have this, and then this. Ooh, that's bad. So I'm just redraw the molecule. So the two vacancy is now going to be here and here. Okay. So if the other reactant is H2O, basically what happened is the OH is going to be added to one carbon, and the H is going to be added to the other carbon. However, in theory, there is no rule in terms of which carbon is going to take the OH and which carbon is going to take the H. So this is only one of the two possible products you can have. You can make this, or this is a lot easier on the board because it doesn't take 2 seconds to change the color. Or you can have the opposite, which is, oh my god, alright, I can do this, shouldn't complain since I asked students to draw all the carbon. Or you can have the second case when the H is added to the first carbon and the OH is added to the second carbon. So you can either have propan 1O or propan 2O. And there is really no other way, no way to control this. Actually, there are, but we're not going to go through them. Can you have a mixture of both? Maybe. So you could have a mixture of propan 1O and propan 2O coming out of this reaction. Because, again, when a reaction happens, you have more than one propene as your molecule, as your starting material. Now, the catalyst is phosphoric acid, or H3PO4. This is a catalyst, and 300 Celsius degree also require high temperature. So the H2O actually definitely exists as steam in this case. There was one year when students have to write H2O in, and a lot of people wrote H2O liquid out of habit and lost the math because it should be a gas in this reaction. Okay, next thing, halogenation. Addition of a halogen to an alkene under SLC condition. So what looks good? Let's use, I don't know, butylene. I'm not drawing pentene though. It's too many hydrogen. I feel like I could copy and paste here. I need a better program than this. This is just PowerPoint presentation. Okay, so we have this. We're gonna break the CC double bond. What is the program that's used by like Khan Academy? I think he made a video on the program, but I haven't seen it. Anyway, so you can break one of the bonds, and the bond being broken here is going to be in the middle. So the addition obviously can only occur where the double bond originally is. You cannot add the two groups on this carbon because it's already saturated with hydrogen. It has to be in the middle. So if I replace the reactant, originally it was a H2O before, so if I just have it as Cl2, for example, ew, that looks like an A, Cl, okay, then the Cl goes here and Cl goes here. Now because these two atoms are identical, it really only has one possible product. But notice how you're going to get both chlorine atoms at once. So you're not, this is very, very different from a substitution reaction. If I have a substitution reaction, I can only replace one hydrogen with a chlorine atom at a time. Whereas in the case of an addition reaction, you're going to, what's the word, added both chlorine atoms at the same time. So you're always going to end up with a dichloro product instead of just a chloro product. Okay, so that's addition. Obviously, if I replace this with Br2, then you have another, you can have Br here and Br here. So it's not just chlorine. It could be chlorine or Br2. A little bit on fluorine. We'll not talk about fluorine and iodine too much, but a spin-off, if you will, of halogenation is what is called the unsaturation test. And the unsaturation test, as the name suggests, is a test for unsaturation. My God. Essentially, it's a test for the presence of CC double bond or CC triple bond in an organic compound using bromine. Now, bromine is a liquid that is orange brown, and if it undergoes a chemical reaction, so if the bromine, the two atoms of bromine dissociate from each other, so if this bond is broken, essentially the solutions it's going to go from liquid brown to catalyst. So there's a color change that can be observed, and you can use this to detect whether or not CC double bond or CC triple bond are present in an organic compound. Because if you go back to this reaction, and I can write the same reaction for bromine, it doesn't require UV light. So if we think back to substitution of alkanes. Alkanes can react with a halogen. So alkane can undergo a reaction with bromine to produce bromoalkane. However, that reaction could only happen under UV light because you need a lot of energy to break a single covalent bond. However, an addition reaction with halogen doesn't require UV light, so does not require UV light. So it can happen, and you may see this in some textbook. It just say dark room. It's a very, you can say like I can turn the light off it, and it probably still happens, but it can happen under SLC. So no UV light. Okay, dark room. There you go. So if you mix bromine water, which is orange, to a chemical sample and not supply UV light, if you see no change in color, then that substance must be saturated. But if you see a change in color, then that substance is unsaturated. It most likely has a CC double bond, or it can also have a CC triple bond. So you can use the change in color of liquid bromine to detect whether or not CC double bond or CC triple bond are present in an organic compound. So this, if something is saturated, it only turns colorless if you shine UV light through it. But obviously, why would you do that? So that's the unsaturation test. Lastly, actually no, that's not the last. This is not the last one. There's one more after this. Addition of hydrogen halide. So HX looks really scary, but HX is just a general form of halogen. So it can be HCl, HBr, HI, generally these two. So let's say I have, okay, let's do propene again. So I have this. And again, this is an addition reaction of alkene. So you're going to break one of the bonds in the CC double bond, so you end up with this. Okay. Now if the other reactant is HX, let's just go with HBr this time. So let's say if we have HBr, then this is another situation when you can have two different possible products. You can have the hydrogen being added to the first carbon and the bromine being added to the second carbon, or you can have the opposite. Okay. Or, and in a lot of cases, you're going to have a mixture of both products being present, and then you have to try to separate the two products. What happened to the... Okay. You really want to think about how you're gonna separate these products from each other. What technique can we use to separate these two? Now that's a question for chapter 13. All right, so you can have either of these two products, okay? Most of the time a mixture of both. Last but not least, I don't even think this is the focus of year 12 anymore. We talked about this last year. People were very bad at it, but this is addition polymerization. A lot of the time self-addition polymerization, but it doesn't have to be that case. And essentially it is when multiple alkene molecules can be added to each other to form a polymer, an addition polymer. So let's say, for example, if I have ethene, if you have multiple ethene molecules, and they all break one of the CC double bond. Now this is only a representation of the polymerization process. You also need, most of the time you need to add an extra thing so you can actually seal off the two ends of the polymers. But let's say you have, okay, I'm gonna draw like three. There's another one, so I just want to show you a different color. It is the exact same molecule. So this one also break the CC double bond. Essentially, if they all break the CC double bond, then they can be added to each other to form a long chain of alkene. Let's do another one. Let's do three. Let's do three. Okay, so this is this one. So you can have C, C. So you can have that, and it can continue. And so it's basically this is ethene, and the polymer that is going to be formed is called polyethene, or PE. Now you have LDP and HDP, so high density polyethene and low density polyethene, which I think LDP is like plastic bags, and HDP, you know, you have like a laundry bottles, and if you will see like the little triangle thing like this. If it has like a number 2 in it, that's HDPE, so that's high density polyethene. So it's made from this thing basically. And I'm gonna say number 1 is LDPE, or low density polyethylene. It's actually going to be very hard to find this because most plastic bags doesn't have the little recycling symbol next to it. Okay, so that's addition polymerization. It is a lot more complicated than this, but I think for now let's just stop with this, and then we'll do more examples in class. I have some steps for drawing the polymers and identifying the monomers, but once again, I'm going to talk about this in class more because I think this video is already too long. I just want to give you a few more examples of the other types of addition reactions. So I think your goal right now should be to understand the other types of addition reactions, and then we'll talk about addition polymerization later. Okay, use structural formula to complete the following addition reactions. So this is the first one. I think I drew this before. Oh no, I did butene or something. Okay, so if you want, one way to start is just to redraw the alkene, but break the one of the bonds in the CC double bond, which is going to create something like that. And you can clearly see that these two carbon hasn't had 4 covalent bonds yet. So I have these two left hanging, and then just put the chlorine to it. Voila, finished. What's this called? 1,2-dichloro propane. Okay, next is this one. So working backwards. Now, you can clearly see that this is an addition reaction. Did I talk about this? Oh, I haven't talked about this, haven't I? Oh, okay. You can also add an ammonia. Sorry about that. I add a slide on this. You can also add an NH3, and then you're gonna have again an amine. So the original can be here. Actually, what you can do is just think about the fact that two groups have been added to this molecule. So if one of them is here, the other one has to be on the adjacent carbon. It could be on this side or this side. In this case, it doesn't matter. So these two will form a group. So I have NH3. Okay, so that's originally come from the NH2 here and the H here. And whatever is left, so let's just redraw everything else. So you have these two hydrogen left. Okay. Oh, what just happened? Okay. And you need a double bond here. So let's do a double check. That's not good. Let's draw it again. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Every carbon has 4 covalent bonds. Okay. So that looks good. So you can have addition of ammonia, sorry. This is addition of ammonia. Okay, ammonia. One more example. So this is the last one. So just try to work out where, not the OH here, there must be a hydrogen from the other adjacent carbon. Adjacent just means next to. So this H and this OH is going to form one of the reactants. And if I redraw the rest of the molecule, 1, 2, 3, 4, the CH3 here. Why did I do this to myself? Why did I draw a branch? What does it accomplish? Nothing. Okay, H and 2H. So everything has been redrawn except for the H on this carbon and the OH on the terminal carbon. So you need a double bond here as well. Let's just check. 1, 2, 3, 4. Everything has 4 covalent bonds. Okay, is that it? Okay, so organic pathway. So alkene can undergo addition reaction. What are the different addition reactions that it can undergo? Now this is just varying the other reactants. You can have addition polymerization. So this is when you have alkene reacting with other alkenes. So addition, polymerization. So the other reactant must be alkene as well. So this is going to produce addition polymers. The other addition reaction that you can have is you can have an addition with halogen. So that is going to give you haloalkane. And I think the most common or well-known application of this is the unsaturation test, when you use bromine and observe for change of color from orange brown, which is the color bromine, to colorless. You can also have an addition with halogen, alcohol halide. I can't even know. Hydrogen halide, sorry. HX. Sorry, let's just say HX. So this is addition as well. And that is actually also going to produce. Why did I delete alkane? Okay. That is going to produce haloalkane as well. So there are two ways to produce haloalkane. Either you have an addition with halogen or an addition with HX, but obviously it's going to produce different types of haloalkanes. You can also have an addition with ammonia, and that's going to give you an amine, so alkylamine. You can add H2O, condition H3PO4 catalyst, and 300 Celsius degree. That's going to produce alcohol. And last but definitely not least, you can add a hydrogen. condition, 500 Celsius degree nickel catalyst, and that's gonna give you alkane. So these are all the different types of addition reactions that an alkene can undergo, and you can produce different types of products from that. Is that it? Well, that's it for